All right, so let me start sharing my screen. So let's see here. Okay, can you all see my screen? Yeah, we don't have too many people today. Maybe they all went for a break or something. It is Chinese New Year, I guess. So, oh well. We'll do what we can. Hold on, what is this? Okay. Yes, yes, sorry. Very good. Okay, let's start. Today is going to be a review of our Unit 1 material. So basically, for our schedule today, we're going to go over some missed homework questions that a lot of people missed, and we're going to go over some like all 3 lessons in this unit, and we're going to review. Then, lastly, we're going to do some practice problems involving like the material from all 3 lessons. So for reviews, we're going to have a review at the end of each unit, and it's basically going to be a consolidation of all major topics in the unit. So like lesson 2, we worked on substitution, so I'm going to go over that, and then of course we're going to have problems from all lessons within the unit. And for this unit, it was pretty short unit because it is introductory unit. We're just starting to get to the fun stuff. In our unit 2, we'll be working on linear equations, I think. So that's really when we get to like the more difficult stuff in Algebra 1. So let's do our homework questions first. There's 3 of them that some people missed. And of course, I did put a challenge question in the homework, so that made it 6 questions. And some people did attempt the challenge question, which I'm very happy with. So that's good. And then, but some people did miss it or didn't understand like the comma in between. So I'll explain that later. So let's first go over this first problem. It looks very daunting, very frightening because there's so many terms, right? But that's usually the case when you're working with combining like terms, right? So make sure you just list out the similar terms, like terms, and then you add them together, and make sure you check your work thoroughly because this is when you're combining like terms, this is where you usually make mistakes, right? So make sure at least do it like twice. You can do it mentally the second time, but so it's good to check your answers thoroughly. So can everybody just put your answers to this question in the chat, and then I'll go over this question. Okay, so we have 12a to the 6th plus 2b to the 4th plus 7a plus cd. All right. Any more answers to this first problem? I'll leave it up for a couple moments, and then you guys can put your answers here. All right, we've got 4 more answers. So we got CD plus 12a to the 6th plus 7a, about the same stuff. William says 12a to the 6th plus, but without the 7a, and then we have a minus 7a plus 26. Right. Okay. Oh, you just mixed up the numbers. Okay, that's fine. And then, yeah, basically the same stuff for everybody, which is good because that is the correct answer. So let's go over how to do this. I'm just going to use different colors, but you don't have to do that when you're doing your homework. Just it's good to recognize these like terms when you're first doing it. Obviously, let's just start with 2CD, the first term, and any other CDs. All right. So remember, like terms have to have the same variable and the same exponent. So we have another CD here. Okay, I think that's about it for the CDs. Okay, and then we have the yellow one, 5a to the sixth. So a to the sixth power. We also have a 7a to the sixth. That's good. You have another term, and then I don't have any more left. Let's see. And then we have D. So negative 8D plus 8D cancels out. So don't have to worry about that too much. So if it does cancel out, make sure you mark it so you don't make any mistakes later. And then we have the A terms. So we have those. And then lastly, we just have 2B to the fourth by itself. And that's convenient because we don't have to do anything with it. Let's go back and we have, remember, you have to write your answers in standard form. Okay, so basically the largest exponents or the largest coefficients of the exponents are the same. Okay, so remember, largest exponents, a to the sixth. That's the largest exponent here. So then we have 12 a to the sixth plus, what do we have next? So what is our next term? We're going to have b to the fourth because that's the second largest exponent. It's b to the fourth. We get 2b to the fourth, right? And then what we get? We have cd. So let's also put cd here because we're multiplying two variables, and usually I put two variables before the single variable. And actually, if you could also do it this way. So if you add these two, you get 7a, right? And that the coefficient is actually larger than that. So let's actually put 7a first, and then we put the CD. Okay, so when they're on the same level of exponent, I would just, for the bigger coefficient, put it first. It just looks better. Any questions? No questions? Okay, that's good. So this was pretty easy as long as you didn't make any careless mistakes. So remember again to make sure you simplify your answer and you check it thoroughly. This one, some people did miss, but the last challenge question was what a lot of people either didn't do or just missed. Okay. Let's work on this one a little bit. So make sure you check your answers again when you're going through the homework questions. So put your answers for this question in the chat, and then I'll walk you through it in a couple moments.
Is the 45 supposed to be a 4/5 or?
Oh,
wait.
no. I copied it down wrong. This one is not a 45, it's 4/5.
Okay.
Actually, let me just rewrite the whole thing. Okay. Thank you for reminding me, whoever that was.
You're welcome.
So 4/5, 5x plus 10 minus 9 1/3 y minus 1 plus 5. All right. So just rewrote that a little bit. But if you did do the 45 times the 5, does that equal 225? Yeah, so 225x plus whatever. They'll just have a different x value. All right, so let's see. We have 10 answers. That's good. This is homework from a long time ago. We're actually reviewing the homework because this is what you guys missed a lot because we didn't 5 weeks. I think it was 2 weeks ago because we didn't have a class last week. This was the 1.3 homework. Anyways, let's see. The 5gh plus 5k minus 11. There's no k or g values in this problem. That's the answer for question 2 on the homework. The correct answer should be with x's and y's. So let's see. 4x minus 3y plus 22. Very good. And 4x minus 3g, I'm going to assume that's going to be a y plus 16. So we have all types of answers. Mostly, we also have a 36x plus 6 plus 3y, okay? Okay. All right. So most of you guys got the same answer, so that's good. So how do we do this? This is basically a review of distributive property. So make sure you do this kind of stuff. But also, key point here, subtle point, make sure you do not miss this, that what you're doing here is you're not multiplying 9 to 1/3 y or 9 to -1. You're multiplying -9 to -1. So what a lot of you guys did was instead of multiplying -9 to -1 and getting +9, you guys did just 9 times -1 and you got -9. That changed up your constant in the answer. So make sure you do not do that. Careless mistake. Okay, so let's do it. 4/5 times 5x, so 5's cancel out, so it'd just be 4x. Plus 4/5 plus 10, times 10 would be 8. And then minus 9 times 1/3 of y is negative 3y plus 9 plus 5. So if you just add all the constants, you get 22. All right, so this should be your final answer. Okay, so write in standard form. Any questions? Yes, so a lot of people got the -9 instead of 9. So make sure you multiply the -9 to the -1. Okay. So let's last homework question. This was the challenge question, so it's optional, but I appreciate the people who actually tried, and I did give some people extra credit for that. All right, so for the people who got it correct, I gave them an extra 10 points. All right. So congratulations to anybody who got that extra 10 points. So this one was kind of confusing. So for those who actually got the challenge question correct, so could you just please put your answers in the chat? And everybody just, if you did do this problem, put your answers in the chat, and then I'll go over how to solve this one. Because this one, I got this one from online, or just searching up like what challenging combining like terms problems, because I'm too lazy to actually devise them myself. So then I got this one. It's kind of weird, and it's kind of I don't know. But I looked on the website. Apparently, they want to use standard algorithm or something to solve it. There's not going to be another problem like this. All right, so don't worry about it. I'll still go over it in case there's some confusion. Or you could just like add them normally if you're good with fractions. What they really wanted us to see was like how to, the like terms. Apparently that's what they teach the kids in school these days. Okay. 7/18 p cubed plus 1/4 plus r to the fifth. 1/6 p cubed q squared plus 4/9 p cubed plus 1/4. All right. We have 4/9 x plus. Do we even have an x, or is it just times? 4/9 x plus 2/8. Remember to simplify. It's 1/4 plus 1/6 p cubed. All right. Blah blah blah. Okay. 1/6 p cubed q squared plus. All right. A lot of correct answers. That's good. And we also have a 24/54. Well, I guess you could how you simplify. So 54. You simplify that and you get something like 6. I don't know, 6/9, 4/9. Okay, yeah. It's also 4/9. So make sure you simplify these things, okay? And then yeah. So make sure you simplify. So 24/54 would be 4/9, and then 9/54 would be 1/6. Okay. So let's go over this. Basically, what the website really wanted you to do was, just line up the terms. Okay, so this was kind of confusing. So if you did not know how to do this, no, there's not going to be a question like this ever again. It's just confusing. I'll just, instead of the comma, I'll just put an addition sign next time. Okay. So what they really wanted you to do was to put each of these polynomials or expressions, since we really haven't talked about polynomials yet, so let's just call them expressions. You just put these expressions like this in like kind of like a standard algorithm form. So if you've done standard algorithm, most of you have, it's like this, right? I'm just pulling out random numbers, so don't pay attention to that. And get what? This. Okay, so it's basically using it to subtract and add better. I guess that's what the big idea here is. So what you need to do is you need to put these terms, just put each of these expressions like in standard algorithm form. But make sure when you're using standard algorithm with numbers, let's say we have 593 plus 49, you line up the ones with the ones, and then the tens with the tens, and the hundreds with the hundreds. But in this case, there's nothing here, so that's also the idea here. So basically, we're putting this this equation on top, and then this equation on the bottom. Okay, so let's go back. So our first equation, this big one with 4 terms, has p cubed q squared. Now let's look at our other expression. We don't have a p cubed q squared, and that's kind of like the hundreds column that I talked about in the other example, right? There's no hundreds column in like the 49 or something. So we're just going to leave that there. We can say 0 p cubed q squared because there's nothing there. And then make sure you line up the p, what is it? The p cubed with the other -5/9 p cubed, so -5/9 p cubed. So basically, you're just lining up these terms, and then they kind of tricked us here because they put the constant before this -1/4 r to the fifth. So make sure you don't fall for that. Line up them all correctly. So there's going to be the -1/4 r fifth is supposed to be lined up with this other 1/4 r to the fifth. And then finally we have our 5/8 here. So it's all kind of unnecessary, if you ask me. So of course, I'm not going to give you this question again because it's kind of inconvenient, inefficient. You can just add the fractions, But basically, what this is doing is basically make sure you know how to line up your terms correctly. So if you add the 0 p cubed q squared and the 1/6 p cubed q squared, you're just going to get 1/6 p cubed q squared. And this also, once you're done doing this, it's also in standard form, which is a nice bonus. So p cubed, and then minus 5/9 p cubed, it's going to be 4/9 p cubed. And then you get the 1/4 r to the 5th minus 1/4 r to the 5th. Well, it's basically like 1 minus 1. It cancels out, right? So basically what we're getting here is 0 times r to the 5th. Okay? So there's nothing there. And then you get negative 3/8 plus 5/8. You get 2/8, which can simplify to 1/4. So let's rewrite this as our answer. Always remember to simplify. All right, so this would be our answer. And then of course you could just look at the like terms and then do what you need to do just without doing all this standard algorithm. But what this does is basically make sure you don't make these careless mistakes like just doing it mentally and strengthening your like knowledge of like terms and stuff. So it is kind of useful. Okay, and the chat is exploding. What is this? Brilliant.com. I'm gonna get scammed for sure.
Do not use it. Do not use it.
Then why did you send the link?
Oh,
Why did you send
right,
the link
it
if
said
you
do
didn't
not
want
use
others to use it?
That's sad. Okay,
It says it's not secure.
I know.
Then don't send the link.
Literally?
Okay.
Does it like literally say it's not secure on the website?
Let's go to it again.
Oh, it says in the top corner. Somewhere. Well, for me it said it's very not secure, so don't use it.
Then why don't post the link?
Okay.
How was I supposed to know that?
What?
I just came up with a link. These
Oh,
days
wow.
there's like a bunch of ads for brilliant.com.
Now the teacher's
Okay,
gonna
so
get
no
hacked.
questions. All right, everybody stop having a seizure. We're okay. Okay. Anything these days can be made into a URL. Literally. Obesekids.com is the website. Like, who in the right mind will make that website? But anything you type a word, it's a website. So, kids, you'll get scammed for sure. Anyways, let's go back to our homework questions. Actually, we don't have any. So let's start reviewing from our basic definitions. Of course, we're reviewing very simple stuff. But when you're learning mathematics, it's just like rolling a snowball, right? You need to make sure that your basic skills are down pat, so the snowball doesn't fall over or get crushed when you learn higher level stuff, So that's my excuse for going back to this. So basic definitions. We're reviewing a variable. Pretty sure you guys know this already, but just review. This is supposed to be a review lesson, so I'm just reviewing stuff. Okay. A symbol or placeholder that represents a quantity or identity that may change. So examples of variables. Everybody give me examples of variables. Oh, come on. It's not a website. That's dumb. They should make a website on that.
Yeah.
Stop filling chat isn't even a website. How about they make a website about scam.com? then nobody would actually, if you tell something, let's say if you made a website named scam.com.
Hey, look at the new .com. It's called https zoom.com.
The real website, of course it is.
Yeah, of course.
I'll be surprised. No, what if you change it into org? Zoom.com, zoom.org.
Organization?
This is not a scam.
Org, org is like a definition. Org is like, that's actually a real thing.
What the heck?
What?
Oh,
What the heck?
All right. So let's go back. Everybody, stop
That's
having
a
this
weird
feature.
one.
We're done. All right. So examples of variables: we have x, we have y, we have z, we have w, we have n, we have t.
basically the entire alphabet.
Exactly. Whoever that said that. You can also have a star. I'd like the star. Touch of the originality. Okay, expressions. A valid combination of mathematical identities with at least two terms and one mathematical operation. Okay, so let's review what's in an expression. Okay, so just an example, 4x plus 7. Okay. So we have our, let's not do that. That's dumb. Okay. 5x plus 7. The 5 is a coefficient. The x is the variable, obviously. And then the 7 is called a constant. Because no matter what you do it to it, it's not going to change. It's a constant. 5x, it can change. Depends on what the variable is. That's why it's called a variable. It can vary, you know? So the coefficient, 5x can change. Let's say variable is x equals to 2. Then 5x would be equal to 10. Okay? But no matter what x is, 7 is never going to change. So that's why it's called a constant. Okay, I'm going to go very fast on this one. Equations, same thing, except equal sign. So 4x plus 7 is equal to 0. Or 3x minus 7 is equal to 1. Okay, so this is the key point here. Key point. Must have equal sign. Okay? So if it doesn't have an equal sign, it's an expression. If it does have an equal sign, it's an equation. Okay, we're done. Basic operations, you know all of this already. So addition, subtraction, multiplication, division. And then we also added some new ones that you may not have seen yet in your 6th grade or 7th grade, you know. So we have a to the n, basically a to the nth power. Okay, you have a squared, you can have a cubed, a to the 4th, you know. And then we also have a to the nth power, nth root, where it's like, so a to the nth root times a to the nth root times n to the 8th root, dot, 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 n times is equal to 8. Okay, it's kind of let's write it down for you. So a to the n times, a to the n times, dot, 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 times a to the n is equal to 8. This is going to be n times. Basically, n is a number where you have like a to the cube root of a, so the cube root, so let's say a is 27, right? The cube root of 27 is 3. So if you apply this, whatever this explanation is, you know, this thing, then 3 times 3 times 3 in times, right, would be equal to 27. It is equal to 27. So I think that's the best I can provide an explanation for you. So when you go to higher level mathematics, you know, like algebra 2, you'll be working a lot with nth root and stuff. So we're not going to work too much with the nth root. We're just going to do like square roots. Okay, so square roots you all know, right? Square root 144 square root is 12. 36 square root is 6. So this one, not very popular. But the a to the n, you must know. And the other four, division, multiplication, subtraction, addition, that's the purpose of this basic operations, all right? Working with operations, distributive property, combining like terms, order of operations. That's what we're doing a lot. So let's go over it again. So we have what PEMDAS. P is for parentheses. And we have exponent. Remember, it's not the M before the S. Okay, the M is with the S. Okay, so you go left to right. When you have 3 times 4 divided by 3 times 2, you don't do the multiplication first. You'll do 12, then divided by 6. Or you don't do the division first. You don't do 4 divided by 3, and then do all of the rest of the multiplication. When you have multiplication and hold on, I'm doing this stupid mistake. It's a D. Okay. When you do when you do this, when you have multiplication and the division on the same line, then you go left to right, right? You do 3 times 4 and then divide by 3 and then times 2. Okay, so common misconception, you do the multiplication first. Okay, and then what you have, the A and the S, also left to right. Okay, so same principle. Okay, and the parentheses. Okay, parentheses is always first, or absolute value. Okay, absolute value counts as a parentheses. So let's say you have 3 times 3 minus 4 divided by 2. Okay, there we go.
Wait,
Perfect example, not really. But so when you have absolute value, make sure you do the absolute value first. Okay. Basically same value as parentheses.
Are square roots part of exponents?
Square roots. Square roots could be part of the exponents, but we'll talk about more about that later, because basically, if I were to explain it to you now, the square root of a is basically a to the 1/2 power. So I guess it is kind of exponents, I guess.
Oh, okay.
The letter n and the square root of a, is it like n times the square root of a, or like?
No, n is, so if you had n times the square root of a, it would be big like this. But no, this you don't have to worry that much about it. So when you get, let's say you all know the square root 36, right? 36 is going to be equal to 6. Usually we don't put the 2 there, but this is what actually is the square root of 36, because this is like the second root of 36, I guess. So don't worry too much about it. Okay, we're not going to be working too much with this nth root thing. Okay. But we will have a chapter or unit on radicals, and we will get there when we get there. So hang on. So substitution, plugging in a mathematical expression, and I tweaked this definition a bit from last time. So it's basically not plugging in like a numerical value always. Okay, it's going to be plugging in a mathematical expression. Okay, usually it's a numerical value for a variable in an algebraic statement. Usually in algebra 1, in these early stages, we're just plugging in numerical values. But when we're working with like systems of equations in later units, we're going to be plugging in like other things. So let me give you an example. Let's say we have y squared plus x times y minus 4 plus 2. Okay, and then let's see, let's have x is equal to y minus 2. How about that? Okay, so usually when we're in algebra when we want to have like the same an equation or expression with the same variable, only one variable, so it's easy to solve for that variable. So if you know that x is equal to y minus 2, then you can substitute it in because you can use them interchangeably because they're the same value. So then you get y squared plus y minus 2 times y minus 4 plus 2, right? We just substituted in for x. So that's an example where you're plugging in a mathematical expression instead of like a numerical value. But then you could also have like 3x plus 2y, and then x equals to 2, y equal to negative 3. Then you could plug it into like this. Basically, substitution is just interchangeably using values that are equal to each other. Okay, that's the big idea here. Okay, so combining like terms, we did this in our homework questions last lecture. So like terms basically are mathematical terms that share the exact same variable and exponent. Okay, and the exponent has to be the same. So 7a to the 6th is not a like term with 5a to the 5th. Okay, if you do have a 5a to the 5th. These are just random examples. Okay, so not only does the variable have to be the same, the exponent also has to be the same. So if you have x squared plus x, you can't combine them. Okay. Usually some people not very good with algebra, they combine x squared plus x equals to x cubed. Does not make sense. Okay. So like terms, people give me how about you guys give me some examples of like terms? What the heck? How many chat messages was that? Having seizures. Everybody is having seizures. Okay. Let's see how many. So last chat message. There's a lot of chat messages. Oh wow. Well, and then hack your fridge and other computers. Okay, what am I looking into? Okay. Pointless.com. We're gonna get scammed. Oh, actually, website.
It's a clock. It's a clock.
I guess that's useful. It's an LLC. What's that? What the heck is an LLC? Supposed to be an incorporation or something. I don't know. So yet,
It might as well mean lost property of a company. I don't know.
you have 6G and then 9G. So like terms. Let me just give you a bunch of examples. They're kind of running out of time here, so you have unlike terms here. All right, so let's just use x as an example. So 7x squared. And then we have 5x squared. Same thing, right? So like terms. Unlike terms. 7x. And then 4x cubed. Same variable, but different exponent. All right? So make sure you have to have both the exact same variable or the exact same exponent. All right, we're done with that. Distributive property, you guys know very well. A times B, then A times C, get AB plus AC. Basically, you're just distributing the A to both the B and the C. So then you get AB plus AC, basically distributive property. So I can also explain associative and commutative property. So associative property. Okay. Let's just give them both a box, I guess. Associative property, what that says is with parentheses. So when you have something like with addition or division, I mean not addition, not division. Okay, only addition and multiplication. Okay, so division doesn't count. Division and subtraction, it matters. Okay, it matters. But with addition and multiplication, you're just adding things on, so it really doesn't matter. With parentheses, a plus b, the quantity of a plus b, the parentheses, the a plus b, and then u plus another c. That's basically just equal to a plus b plus c. So that's associative. You can put the parentheses anywhere if it's all like addition, or all like a times b times c is equal to a times b times c. Okay, same thing. So then you have commutative. That's how you spell it. Property. Okay, basically a plus c plus b is equal to a plus b plus c. So it also works only with like addition or multiplication. Well, I don't really work too much with these because it's basically simple. Like if you do math long enough, you already know all of these. So and then for multiplication, same thing. Just switch up the terms, right? So basically, example, 3 plus 4, same as 4 plus 3. Okay, common sense. Not really, but let's just say it is. Okay. It, isn't that commutative? Recall. Don't click. I love getting rickrolled. The song isn't even on that. That's lame.
What the heck is that?
It's Rick Astley in his head. You just got rickrolled.
What is that? I don't know what that is.
That
Oh
is
well.
the saddest Rickroll I've ever seen in my entire life.
Okay. So let's go back. Practice problems. Finally, I can peacefully wait for you guys to put your answers. Not really peacefully. You're gonna spam the chat on you with links that are rickrolls. Yeah. Okay. Practice problems. 1 plus 3 times the absolute value of negative 4 squared minus negative 8. So make sure you know that the absolute value is basically the same as parentheses, same level as parentheses. All right, so you're going to do the absolute value first, okay? And then of course within the absolute value you're going to have the parentheses. So within parentheses, order of operations still applies. Okay. I'll give you a few moments to do this problem. Shouldn't be too hard.
Wait, what's a rickroll?
What's a rickroll? Oh, you do not want to know. Okay.
It's a person named Rick.
Yes, and he's singing.
What? I don't
see
get
the-
it. I still don't get it.
Person
you
named Rick, and
Go
he's
on
singing.
YouTube and look it up.
It's just like a prank where people just send you links that you think are one certain thing, but then when you click on it, it just becomes the music video by Rick Astley. Yeah.
Huh? Who's Rick Astley?
He's a person that's randomly.
Search it up.
singing.
Huh?
Search him up.
Who the heck is Rick Astley?
Search him up.
Wait, no. For that person who doesn't know what a rickroll is, how about you go on YouTube and search a rickroll and click on the first video?
The official music.
You'll get
video.
rickrolled. You'll get rickrolled. Yay.
I'll look at it.
You have
I'll play it while you watch it.
That would be
69
hilarious.
Kids, 69 is incorrect. Why? Let me go over this. So, do the absolute value.
81? Is it 81?
It is 81. Congratulations to whoever that said that. Okay, so this is the tricky part of it.
What do you guys say? I didn't hear anything.
I don't know. Anyways, do the absolute value first. So 1 plus 3 negative 4 squared So after in the absolute value, okay, so this is the very tricky part that a lot of people miss. All right. Negative 4 squared. What do you think should be done? Should it be negative 16 or 16? Okay. Think about it this way. Negative 4 squared is negative 1, negative 1 times 4 squared. Okay, then you get negative 4 squared. Do the exponent first and then add the negative sign. Unless the negative sign is in parentheses like this, it won't be positive. Okay, so this one is negative 16 plus 8. All right. And then what do you get? 2 times the absolute value of 3 plus negative 5 squared. Now, the negative sign is in the parentheses this time, so it's going to be 25 plus 3, so 28. Right? Okay, so absolute value of negative 16 plus 8 is good. Absolute value of negative 8, so 8. So 1 plus 3 times 8 is going to be 24, plus 2 times 28 is 56. 56. Okay, then you get 81, right? Any questions on this? Any questions? Okay. You don't know what a meme is? All right. All right. How about you search up a meme on the internet? You get a lot of them. It's basically something, a joke, I guess. Yes, a joke. Kind of. I don't know. All right. Second,
That's the definition of meme. I put it in the chat.
it's the definition of meme.
Wait, did you search it up on Google or something? Cause
Yeah.
it doesn't seem like it.
An element of a culture or system of behavior that may be considered to be passed from one individual to other by
Okay, that definition is like the most boring definition of meme ever.
I know, right?
the scientific definition.
Thanks for explaining it to me. I totally understand what it means now.
All right. Let's do this problem. Okay. I'll give you a few moments to do this. Looks very frightening. It does. It is frightening.
Wait,
So,
brackets are supposed to go outside of parentheses? I thought brackets went inside parentheses.
no, parentheses, parentheses, square brackets, curly brackets. That's
Wait.
the one.
Dude,
Wait, can this happen? Like, I'm gonna send it into the chat. I haven't sent it into the chat yet. Wait up. Okay, can this happen?
This,
Like that?
well, it really doesn't matter because you could say 3 plus 2 and then another parentheses. So
English.
it's like,
Is that a yeah now or not yeah?
I don't know. Math is not like English. It doesn't make sense a lot of the times. So yeah, I don't
for
know.
absolute
I
value,
hate
where,
English.
for absolute value, where does it come on like the order of operations?
Same as parentheses. It's the first thing you do. Basically, you could say it's like a special parentheses. Everything in it is positive, I guess.
Oh, okay, I get it.
All right. Well, we are running out of time, so everybody, if you did do the problem, put your answer in the chat. I'm going to just go psycho mode and just solve this. Okay.
Math is
Always do the
totally
top first. I guess it's just easier to go to top from bottom. So, let's do these square brackets first. But we can do the exponents if they're not in the parentheses first. Just go as we go. Negative 3 squared, 9 minus 12 plus 1 minus negative 10 minus another negative 6. So how do we do this? Negative 10 minus negative 6. That's these two negative signs cancel out. It's going to be plus. What those old school teachers do is like they do this plus. Okay, so now you have this. So it's negative 10 plus 6 is going to be -4. Okay, so 1 minus -4. Okay, so again, you have 1 minus -4. You have two negative signs again, so it's going to be positive. So it's basically 1 plus 4. Okay, so now we have addition and subtraction. Here's going to go from left to right. So 13 plus 9 is 22, minus 12 is 10, plus 1 plus 4 is going to be 15. Great. So then you have this very daunting task below it. But first, let's just do the brackets. It's going to be fine. So you get, in the square brackets, first, you're going to get 4 plus 5, right? That's going to be 9 divided by something. Then you get this. Okay, so there's 16 minus 9 and 4 minus 3, which is going to be 1. So let's just go ahead and do that. Minus 8. Good. Okay.
Is that 1 in
plus 12.
parentheses?
What?
Is that a 1 in parentheses
Yeah,
after?
it is a
Oh.
1 in parentheses. So after you've done all of that, make sure you do not forget order of operations. Do the -9 times 1
I'm
first.
dizzy.
Okay. You are dizzy? Okay, I'm dizzy too.
Call 911.
Yes, you should. But the emergency room is going to take a lot of money, so I don't think your parents will be very happy with that. Frankly, I wouldn't be very happy either. So 9 divided by 16. Let's actually do the square bracket first. So 16 minus 9 is going to be 7. Minus 8, I mean -1. The 9 divided by -1 is going to be -9 plus 12 is going to be 5. Okay, -9 plus 12 is 3. 15 over 3 is 5. Good, great. Okay, next one, evaluate all this. So again, we are running out of time, so let me just walk you through this. 6z squared minus 9z plus 12 squared. Great. So, first step. What is our first step? Substitute it in, all right? Because they're equal values, can be used interchangeably. Make sure you do not forget this, because we are squaring the whole thing.
Oh.
All right, plus 12. No, that's gonna match it up. Okay. Then now you can solve. So you have 6 2/3 squared. How are you going to do this? Are you going to do 6 times 2/3, which is 4, and then 4 squared? Or are we going to do 2/3 squared and then times 6? What are we going to do? Well, obviously, by the order of operations, we're going to do the exponents first, all right? So we're going to do 2/3 squared first. Let's do that. So then you get 4/9, because basically a over b squared is a squared over b squared. Then you get 6 times 4/9 minus 9 times 2/3, which is 6 plus 12 squared. Okay. So after you do that, you get 6 times 4/9. So it's basically going to be 24 over 9 minus 6 plus 12. I don't want to do that, but I need to, so let's do that. 24 over 9. Let's simplify that. 24 over 9. What's that? That's 8 times 3 over 3 times 3. So it's going to be 8/3. So 8/3 minus, what can't I write on this? I can't write anymore. Hold on. This is weird. It's having a seizure. Oh, there we go. So then we get 8/3 minus 6. And in this case, if we, what is it, the common denominator, get this, plus 12 get this. Okay, so we have negative 10 plus it's 26 over 3. Wow. It's a very ugly number. But okay. So then what we get? 26 over 3 squared. Calculators out, people. Calculators out. 26 squared.
It equals 676 over 9.
600 what?
26 over 3 to the power 2, 676 over 9.
Great. That's good. Except now we have to simplify. Can it be simplified? No, it can't. That's sad. Okay. We're done. We're done. I'm not doing this anymore. All right. Is that the answer? What is this chat?
The chat is crashing. My chat crashed.
Alright. I left for a few seconds and like there's a
Isabella the duck. Who's that? That's my sister's profile picture. Okay. Great. I like this chat. 2 plus 1 equals 5. Am I correct? Of course you're correct. If you get 2 people and plus 1 people, you get teamwork. It's 5. Great. 2
No,
plus
you have to
2
add
equals
purple to the math equation, and then you get 5.
2 plus 2 equal to 10 is not the same as 2 plus 1 equal to 5. Okay, 2 plus 1, 3 people working together, they can accomplish great things. But 2 plus 2 equals to 10, failed cooperation. 2 plus 2 equals to 0. Okay. 26 over 3. And the answer for number 2.
Wait,
What the
what's
answer for number
6
2 is
over to the power? Oh, okay. Wait, is it 676 over 9?
yes.
Do we need to simplify that?
No, it can't be simplified. This
No,
like the most
do an
simplified thing.
into an improper, into a mixed.
No. When you get to higher level mathematics, don't do that. Because they can be confused with things. But the improper fraction is the most simplified that you can get. Okay.
Oh, okay.
Okay, then we get this ugly thing. S equal to 3. Then you have to evaluate all of this. What the heck? Okay, so let's do this. Negative 3 cubed plus 14 3 minus 9 over 3 squared plus
Wait, in
3
the
plus
problem, why went 3? Because it's S. Or did you read the problem wrong?
what?
Because in the problem it's S. No, it's
Yeah. So basically, what we're doing is we're substituting.
Yeah,
three
sorry.
in for S.
Yeah, sorry.
If you were to read the S, it would be negative S cubed plus 14S, blah, blah, blah. So let's do this. Again, do not make this careless mistake. Do not do negative 3 cubed. Well, you get the same answer, but, well, I guess you do, so it really doesn't matter. But like I said, just when it's squared, don't do that. Well, for those who don't understand what I'm talking about, just forget it. Okay, so 3 cubed is 27. And then add the negative sign is negative 27. Plus 14 times 3, that's going to be 42, right? 42 minus 9, okay, over what we get. We do the exponents first, all right? So don't do the multiplication first. Then you get 9 squared, and then you get 81 plus 13. Very ugly number. Then, so we need to do 9, 3 squared, okay? So 9, then times 3, get 27 plus 13. Okay, what is this? All right, kids, how do we do this? Negative 27 minus 9, that is negative 36, plus 32. I don't know what that is. 6, right? 6. So 6 over 30, that's 1/5. Is that what you all got? Probably not.
I got 6 over 40 or
Oh, 6 over
3
40.
over.
Sorry. It's 3 over 20. Yeah. Okay. So I made a mistake there. Is 27 plus 13 is not 30. It's 40. Okay, so then you get 6 over 48. It's 3 over 20. Okay, thank you. All right, and make sure you simplify. If you can't simplify, simplify. A fly crashes into a wall. Okay. Let the run continue for Python class. See you soon. I need to leave now. Great. Go to your Python class. Did you leave already? Bye. Oh, you did.
You
leave
already left.
Oh. Oh well. You can look at the recording later and see that I'm saying bye. Ah, learning Python. That's good. I'm also learning Python. Okay. AI, you know?
Mine must be like hard because like I kind of like gave up after like 2 weeks.
Yeah, Python is kind of hard. It's weird. It's not really, but who in their right mind would name something after a turtle?
Bye. See ya.
All right. Yes.
Bye.
Next
Wait,
problem.
Is the thing
Bye.
is it finished?
Yeah. Thank you.
Wait, what?
We're not even done.
Is the class done?
No, not really.
Why do
But I
people?
guess people have to leave.
It's almost
I don't
done.
know.
but it's
Somebody,
not-
I don't know. Somebody just said bye, and then like everybody left.
It's a chain reaction, okay, people?
Dominoes. Okay, well, we still have one more example. I guess we cannot do this. It is kind of easy one. So if you do want to end here, we can end here. Because this is our last practice problem. So let's just end here. We already went over time. So sorry about that. I went over time for 3 minutes. So that's not
Isn't the answer 6x minus 2y plus 5 over 4? Because like, oh wait, no, wait, never mind, just like ignore everything I just said.
I can see where you're going there. Because yeah, I can see how you're thinking that, because you just distribute the 2 to the 1/2 and then it all cancels out. Kind of, right? But that's not the case. So make sure you do the square brackets first, and then
Distributive property. I am so sorry.
Okay, so then you get whatever answer that you get. I don't know. I don't want to do it anymore. All right. Oh, we have one more. Screw that. Thank you for listening, people. Okay, I'm getting paid for this. I need to go back. 5 people visited a local restaurant to get some lunch. A burger costs $6. A bottle of apple juice. Oh my god. Costs
That is
$2.
pretty expensive, you know.
It is very expensive. What is it? Premium burger, premium apple juice. Okay. If all 5 people ordered a burger and a bottle of apple, oh my gosh. No distinction, you know?
These
All
people
order a premium-
billionaires.
Well, not really billionaires. I can afford it too. I mean, it's $8 for one person.
Rip.
I can buy
This
like
is a
8 bags
scam.
of Dorito chips. But okay. Write a numerical expression to show the amount of money the restaurant made for this order. So we have a burger. A burger, $6. Okay. We have our apple juice is $2. So one person is 6 plus 2, right? So then if one person is 6 plus 2, then multiplied by 5, that's our answer. So basically, they made $40. That's kind of sad. People are getting scammed with burgers and apple juice that cost $2.
Won't
Well,
they like sued for like scamming and stuff?
I don't know. Oh, if it's expensive, why would people go there? I guess it's fair. I mean, if it's organic apple juice, then they're probably gonna charge. But who cares about organic apple juice?
Go to McDonald's. McDonald's actually kind of sucks.
The health
It's
nut.
like-
I hate McDonald's.
I don't like McDonald's.
McDonald's is like the cause of the obesity pandemic. Don't go there. There's too much oil, you know?
Ew, like if if you like squeeze the oil out of a burger, it might be like filling up like I don't know, a really tiny bucket, but that's still like a lot. It's really gross.
Exactly.
That sounds
Like, there's
disgusting.
all of those TikToks on McDonald's stuff. I don't know. Oh well. Last example. Thank you for listening, people. Bye. I'll see you later. If you do have any questions, ask them now because I don't care.
Thank you.
Bye. I probably shouldn't have said that. Okay.